Hello everyone! Welcome to our very first lesson in basic calculus, the limits of algebraic functions. This is Miss Jen
And Callie,
your learning buddy.
in today's lesson, we shall explore the meaning of limits through its graphs and table of values. We will also discuss the laws governing limits. Be ready with your scientific calculator and graphing application because it will make the process easier. First, let me share with you a story. Attracted by the beauty of Kitindai Underground River in Havalyar Albay, John and his friends had an exciting adventure before the pandemic. They have hiked a rocky trail to reach the spot where they could have a good dive. But when he was about to jump, he can only stay just near the edge because of the sudden danger he had perceived. This feeling gave him an experience of limits.
The concept of limits has a wide range of applications. For example, pharmacologists use limits to calculate how much of a drug remains in the bloodstream over time, which helps in determining safe dosages. In transportation, as a car accelerates, the limit of its speed accounts for factors like air resistance and mechanical constraints, defining its maximum possible speed. In physics, limits are used to find the instantaneous speed of an object by analyzing its velocity over time. In economics, limits model how a company's revenue or profit grows and approaches a sustainable long-term value. Similarly, biologists use limits to study population growth, which eventually reaches a carrying capacity that the environment can support. Engineers use limits to determine the maximum stress a material can withstand before breaking, crucial for designing safe structures like bridges. Environmental scientists also rely on limits to forecast long-term changes in temperature and sea levels as key factors like carbon dioxide concentrations increase over time. In conclusion, understanding the concept of limits is fundamental in mathematics as it forms the backbone of calculus and helps in the exploration of complex functions. Limits allow us to analyze and predict behavior as variables approach specific points or infinity, providing insight into continuity, derivatives, and integrals. This concept is not only essential for solving theoretical problems, but also has a practical applications in fields like physics, engineering, economics, and beyond. The mastery of limits equips students with a deeper appreciation of how mathematics can model and explain real-world phenomena. Having explored the wide-ranging applications of limits in various fields, we now turn our attention to understanding how limits function within algebraic expressions. Limits of algebraic functions are particularly important because they allow us to analyze the behavior of these functions as inputs approach specific values.
We try to understand the limit of a function in x as x approaches a certain value. In symbols, we have the limit of f of x as x approaches a. This is read as the limit of a function in x as x approaches a certain value. Let's say our function is f of x equals x plus 1, and that certain value is 3. Mathematically, we write it as the limit of x plus 1 as x approaches 3. Looking at the graph, we consider that portion at which x is equal to 3. This point, having coordinates 3, 4, then divides the graph into 2. The right portion and the other as the left proportion.
Take note that we can start from the left or from the right in approaching x equals 3.
Take a look at the arrow as x approaches 3 from the left. The function f of x approaches 4.
In symbols, we have the limit of x plus 1 as x approaches 3 from the left is equal to 4. On the other hand, as x approaches 3 from the right, take note that the function approaches 4. In symbols, we have the limit of x plus 1 as x approaches 3 from the right is 4.
Since the two sides of the function approaches to the same value as x approaches 3, we therefore conclude that the limit of x plus 1 as x approaches 3 is 4. Let's verify our conclusion through a table of values by evaluating the function with appropriate values of x. Let's have first the left-hand side of the limit. In symbols, we have the limit of x plus 1 as x approaches 3 from the left. In this case, consider only the values from the left of 3. For example, we choose 2. Evaluating the function, it will result to 3. If we will choose 2 and 5/10, evaluating f of x when x is equal to 2 and 5/10, we will have 3 and 5/10. Do the same process for each chosen value. As much as possible, we have to choose a value from the left side of 3 that is much closer to 3, such as 2 and 99,999,999 millionths. Evaluating the function, it will yield to 3 and 99,999,999 millionths. And if we choose a number that is much closer to 3 from its left, the value of the function gets closer to 4. Therefore, the limit of x plus 1 as x approaches 3 from the left is 4. We do the same as we evaluate the limits of x plus 1 as x approaches 3 from the right. We start with x equals 4. Evaluating the function at x equals 4, we will get 5. Now choosing a number that is much closer to 3 from the right, we will arrive at a much closer value to 4. Hence, we say the limit of x plus 1 as x approaches 3 from the right is 4. Notice that if we choose a number that is much closer to 3 on either side, we have arrived at a value that is much closer to 4. Since the limit of x plus 1 as x approaches 3 from the left is equal to the limit of x plus 1 as x approaches 3 from the right, we conclude that the limit of x plus 1 as x approaches 3 is 4. This supports our answer when we have considered using the graph of the function f of x equals x plus 1. In this example, the limit of f of x as x approaches to a is just f of a. With this, we can get the limits of the function either using graph of the function or using the table of values. From this, we can have the following key points. First, the limit of a function f is a number L that the values of f of x approach as x approaches a certain number a. It is written as the limit of f of x as x approaches a equals L if it exists. Second, the limit of f of x as x approaches a exists and is equal to L if and only if The limits of f of x as x approaches a from the left is equal to the limits of f of x as x approaches a from the right, which is equal to L. Lastly, we can evaluate the limits of a given function y equals f of x by using either tabular method or graphical method.